Hello everyone, and again welcome to the Magnetic Brains. This is me Adesh Shrivastava, and today where I was left with the chapter sound, as we are going with the series to complete the full one-shot video for you all to just crack the sound chapter. Alright, be a master of the chapter sound. So in video first, as we have talked about a very good of sound, basically their features, how the sound propagate, what are the disturbance, how it is produced, everything related topic sound. And I promise you all that I will tell you the characteristics related to the chapter sound. So first of all, I just want to tell you what is a wave, and as we have talked about the definition of wave, as we have talked about the definition of sound. So what was the definition of sound? You have remember? Yes, a sound is a form of energy which makes us hear. A simple and a quite easy definition. So I told you, sound moves in the form of a curved line, and basically that was a wave, as I told you about this. So as I'm going to today tell you about the definition of wave, basically that curved line was your wave. I told you. I think you all remember. Well, as if we go more further on talking about the definition of wave, so in front of you on a screen, I hope so you are able to see. So a wave is a disturbance produced in a medium as the particles of the medium vibrate. When the particles of the medium vibrate, it produced some disturbance, and that disturbance basically is your wave. Now the second point of the same of the wave says that the particles produce motion in each other without making forward or backward. They do not push the particles to go back, to come forward. No, they make or they produce motion to each other to just move as a curved line. And that curved line, when we observe, is your simply wave. We have talked about this. Yes, very good. I hope so you are enjoying. Well, more is it leads to the propagation of sound. Simply it will propagate the sound. And also, hence sound is often called a wave. So sound can also be oftenly called a wave. So I hopefully solve your problem related to wave concept. You can write these points to crack your question related to what is a wave. Alright, now we'll go more further and talk about how sound travels through air. Alright, how sound travel through air. So basically in front of you some definition has been written, or you can say some factors are present on your screen. We'll look one by one. We'll solve what is written here. When an object vibrates in the air or produces sound. Alright, some reasons of the high pressure, yes, are created of you, and these are called reasons of compression. This is very important and very easy definition. You will when read, you will say, oh my god ma'am, really very tough definition. How we'll understand and how even though we'll write. But when I will tell you, you will be able. Alright. These reasons of compression move forward in the medium as particles exerts pressure on their adjacent particle. What it is saying that how can sound travel through air? Sound basically travel through air by two things. That is your, basically I'm writing on your screen. So read it. Compression and rarefaction. Alright. There are two main points by which sound travel. That is your compression and rarefaction. So right now we are going to talk about the reason of compression. So basically, listen my words carefully, don't worry, that when an object vibrates in the air, you simply know when sound is traveling, it will definitely vibrate or produce a sound is simply written. Some reason of high pressure, I'll tell you, when as I take you an example, like this is an sound, from here sound is traveling, alright, I'm giving an example, you can in the easy way you can understand. From this example, even though if you want to make the example, you can make it and you can just crack it, because you can understand it very easily from this example even though. And you can write in your own words about the definition of compression. So when sound is produced or vibrate, so how it will vibrate? See the diagram very carefully, like this. So there, the area of the, or area I spoke, or even though I spoke some reason of high pressure as written in your definition. This is the reason of high pressure. Basically, it's making a hump like in like at the back of camel, basically. So this reason of hump you want to say, or you want to say a high pressure are created in front of you, and these high pressure or hump like structure basically is your reason of compression. Alright, this is very easy. Hopefully you understand. And this is the depression part. This part is your rarefaction. We have completed both topics in one example. You can write easily. The hump or the high pressure created through when sound is produced is called the reason of the compression. And the depression in the sound when sound produces is called your rarefaction. Alright, well, I so you are all happy with this easiest example that I gave you. Alright, then these reasons of compressions move forward in the median of the as particles. It will move forward, it will move far, it will move far, and exert pressure on their adjacent particles. Alright, adjacent means like this, in front of the particles. It will make some of the forward push to them, and that is your compression of the high pressure area or reason. So hope so I just solved your problem related to the topic reason of compression as we relate this topic to the how can sound travel through air. Well, then here comes more in that question only, that with alternate reason of compression. Alright, there are also reasons of low pressure. And I tell you the easiest way to remember the reason of rarefaction. What I told you? Yes, the depression or hollow. Basically, the depression or hollow you see when sound vibrate or produce. Alright, that low pressure area or the reason in front of you which is observed is called your reason of rarefaction, as we have solved this topic very earlier. Class, very earlier. You can easiest way you can remember this, the hump or the high pressure is your compression basically, and the depression part, low pressure part or hollow part is your reason of rarefaction. Don't forget this easiest way, everyone. Clap for it. Well, now it's there in front of you as the object would move forward and backward, consequently producing sound. The series of compression and rarefaction will be created simple. When the sound will produced forward and backward, it will create some type of compressions and some type of rarefaction. As we have read, it is easy. Very good, children. Now it is said that this will allow sound to move through the air or any medium as well, or any other medium. Sound can travel through these type of compressions and rarefaction that are produced when sound travel from one initial point to the final initial point. Alright, hope so you are understanding. Well, now it's the last of the same question, how can sound travel through air? So if the medium is dense, the pressure exerted on the particles will move more in order to propagate the sound in the vasa. When this type of hollow will be less, then it will just grow it, then sometime it will down, then sometime it will grow. So these type of curved line, or you want to say, or the compression or rarefaction series will be created when sound travel from one point to the another, as in the air we are talking about right now, as we are talking about as an example. So remember this, children. Well, now, yes, in front of you some examples are there of sound wave causing compression and rarefaction. Wow! So as you can see, this is a human ear, and here from voice is just getting out. Alright, so the area of where the particles of the median are more, this is your area of compression, and basically where are the areas are less, means particles are less, that is your part of rarefaction. Then again it is high, means a large number of particles are there present, that is the compression part. Basically less, your rarefaction. Then there is a second example also, the same easiest that I tell you. The hump or the elevation is your compression basically, and the hollow depression or the lower pressure is called your rarefaction, children. Hopefully, now I want you to all to share this video to your every of the friends, so they can also see and learn the chapter sound in this type of easiest way by understanding the example and making the definition by itself. Alright, so just first of all do this. Just share this video to every of your friends so they can also take help from me. Alright. Well, now it's your time to understand the mechanical waves. Alright, what are the mechanical waves? We have, remember, I tell you, yes, a wave that is produced when object to the median oscillate and is called your mechanical wave. And the sound wave are therefore mechanical wave. Sound wave, if you want to say, you can. A sound wave is also called as a mechanical wave when the wave is produced and it oscillate. I gave you an example of the mechanical wave. Basically, when sound travel or a wave travel and the median of the particle oscillate with each other, that is your simply called mechanical wave. And you want to say, if you want to say sound as a mechanical wave, you can say, because a sound is also a mechanical wave. Remember this. Now in front of you, as an diagram is there, what is wave? Basically, wave contain two types of waves, that are electromagnetic wave and mechanical wave. Basically, we have not talked about electromagnetic waves, because in electromagnetic wave we have listened a lot about transverse wave, simple of transverse wave. It includes light wave, rays, interacted wave, and these. So these are the not most important topics that we are going to cover in 9th class basically. Alright, but we are going to look at in 9th class most about the mechanical wave and their types, the most important, which can come to your exam even though. I hope so. You are very confused to related, you want to know more about the transverse wave and longitudinal wave. And you have an example of transverse wave in front of you, water ripples. And longitudinal wave, basically a sound wave. Alright. I know you all are confused and you want me to tell you with an example and correlate to you with the example to making that great definition as the chemistry says. Don't worry, I'm with you. I'll tell you how to make the definition by an example for your both waves as well as transverse and as well as longitudinal wave. But right now I'm just leaving, and on the next part of the same chapter as we are doing the one short lecture of the sound, I'll complete your transverse wave, longitudinal wave, I promise you all. So first of all, you want to do, just share this video to your friends. They can also take some effort. They can also see this video and can use in their studies to crack the physics of their class. So till here I'm leaving. I'll be back with the transverse and longitudinal wave. So don't wait, just press the bell icon for more updates. Thank you. Bye-bye.